Okay, in this session, we will talk about congruent triangles. So we'll talk about congruent triangles, exactly what is congruency and how to identify congruent triangles. And of course, the conditions to establish congruency between two triangles. So now what are congruent triangles? So congruent triangles are triangles that are exactly the same in shape and size. So the shape should be the same and the size should also be the same. Then we can say the two triangles are congruent. Now, if you have two triangles that have exactly the same shape and the same size, it simply means that when you superpose one over the other, they exactly coincide. Yeah, they are like exactly, they are the replica of each other, the mirror images of each other. It's like when you go and stand in front of a mirror, you see exactly yourself, right? So you and your image are like congruent pictures, images. The same thing with congruent triangles. So congruent triangles have exactly the same shape and the same size. So when I say the two triangles are congruent, I need to have some conditions or criteria to establish that congruency. So mathematically, in a layman's language, what is congruency? Same shape, same size. So that is with regard to triangles. Okay. So if I'm going to talk about congruency in a more formal manner, then let's say, okay, I'm drawing a rough sketch, but just to make you understand, if I have two triangles, let's say cat and dog. So we have two triangles out here. And if I say that the two triangles are congruent, yes, the symbol for congruency is this. So if the two triangles are supposed to be congruent, then when I'm going to place one over the other, that is triangle DOG over CAT, they should exactly coincide. A little more into this we'll see later, but first we'll see the criteria or the conditions to prove congruency in triangles. So when two triangles have all the three sides the same, they are congruent triangles. Now, look back at this, look at these two triangles, cat and dog. Now, if I say the two triangles are congruent, firstly, as I said, when you flip it over or rotate it, and you superpose, say, DOG over CAT, it should exactly coincide. As in, angle C should be equal to angle D, and angle A should be equal to angle O, and maybe angle T should be equal to, it has to be equal to angle G. Of course, we know this, the sum of the interior angles for triangle is 180 degrees. And then I can say triangle cat is congruent to triangle dog. Okay, so this is not just about it. Because once the triangles are congruent, the sides also should be the same, because that's the buzzword in congruency. Same shape and same size. So when I'm saying the size is same, look at CA. See, CA, side CA. So CA should be same as DO. Okay. And AT should be same as AT. AT should be same as OG. That is AT here, right? Here. OG is here. And the third side, that is CT. CT should be same as DG. Yeah, should be equal to DG. So this does not mean that every time I just give you two triangles and I say, are they congruent, and ask you to find out whether they are congruent or not, you're going to like measure three angles of triangle, the first triangle, the three sides of the first triangle, and the same thing with the second triangle, that is three sides, three angles, and then show that all the three angles of the first triangle are equal to all the three angles of the second triangle. All the three sides of the first triangle are equal to all the three sides of the second triangle. It is not necessary out here, because the conditions or the criteria to prove congruency in triangles, we have four of them. That is, with minimal criteria, with minimal like information, I can establish congruency. I can prove that the two triangles, given triangles, are congruent. The first thing that we shall see is SSS criterion, or side, side, side. So what is happening here? Side, side, side. Of course, you're given two triangles. Two triangles have all the three sides the same. They are congruent triangles. So the second triangle can be a rotation or a mirror image of the first triangle, or both. Yes, just to give you an example out here, see, uh, maybe I'm just going to give some names like this: triangle cat and triangle dog. Okay, so if I'm going to say the two triangles are congruent, then it's because the three sides of the first triangle cat are equal to the three sides of the other triangle, which is triangle DOG. Now, how do I write the symbolic correspondence? Because this is very important. The order in which I write the vertices is very important, because it tells me it tells me which vertex coincides with which, and which angle is equal to which, and which side is equal to which. That is, which angle of the first triangle is equal to which angle or corresponding angle of the second triangle, which side of the first triangle corresponds to which side of the second triangle, and so on. So let's go with the stroke. CA is equal to DG. Now the vertex opposite to CA is T, isn't it? So we have to go with this. It means I can say that T is opposite to, or I can write T. I'll just put a line here, an angle here, mark this angle out here. Let's say it's X degrees. Okay. So CA, side CA is opposite to vertex X, the vertex T, and we have marked the angles as X degrees here. Now CA is equal to DG. Yeah, side CA of the first triangle, we have the single stroke. See this stroke here and this stroke here. So CA is equal to DG. Yes, that's the first side I'm talking about. So CA is opposite to vertex T, DG is opposite to vertex O. And so this also has to be X degrees. It will be, because of SSS criterion. Now look at the second side, which is AT. AT of the first triangle. And AT is equal to what? AT of the first triangle. Look at the strokes, double strokes. AT is equal to OG of the second triangle, isn't it? So now AT, side AT of the first triangle is opposite to vertex C. Yes, I'll mark that as some the angle corresponding as y degrees. So AT is opposite to vertex C. Now since AT of the first triangle is equal to OG of the second triangle, OG is opposite to vertex, OT is opposite to, OG is opposite to vertex D. So this should be y degrees. Okay. And then the leftover side, that is the third side here, which is that CT. CT, triple stroke, is equal to DO. Now CT is opposite to vertex A. I'll call that as Z degrees. Yes. Angle here corresponding. And likewise, DO, CT is equal to DO. DO is opposite to vertex G, which and the corresponding angle is Z degrees here. So we have three sides, isn't it? SSS. So triple S criterion for congruency. So now this will help me write the symbolic correspondence. I wrote triangle cat on the left hand side of this congruency symbol here. So CAT, C coincides with, C is y degrees. Where is y? It is D. Okay. A is Z degrees. Z is G, and the leftover vertex is O. So CAT is congruent to DGO, isn't it? So I'm just writing it here. CAT is congruent to DGO, and it speaks a lot, because CA is equal to DG, AT is equal to GO, CT is equal to DO, and so on. And of course, the order also says a lot, right? Because vertex C corresponds to vertex D, vertex A corresponds to vertex G, and vertex T corresponds to vertex O. So we have all that here. Next is side angle side. Yes. So if I have three sides of one triangle equal to three sides of the other triangle, the triangle is necessarily, the two triangles are necessarily congruent by SSS criterion, and the other things fall in place. That is, the other three angles will be, the corresponding angles will be the same. The angles will be congruent. That's because of CPCT. Now, what's the CPCT? Corresponding paths of congruent triangles. Yes. Corresponding paths of congruent triangles. Yes. So once SSS criterion is established, we can establish the other things. Fine. Okay. Okay. Next we have side angle side. Okay. So in the first case, I spoke about three sides. In SSS says the two triangles, you have two triangles, two sides, and the included angle of one triangle are equal to the two sides of the, and the included angle of the other triangle. Now, included angle is very important. That's why it's side, and the between angle, the included angle. The angle included between those two equal sides. So the included angle is the angle in between those two sides. Now, the second triangle may be a rotation or a mirror image of the first. In another case, it could also be the flipped over version of, or both. So the same thing here. Yeah, you can just name them. Yes. So cat and dog. So how do I establish a symbolic correspondence? It's very important. Here, triangle cat is congruent to triangle. Let me just write that down, whether it is this. We're not sure. I can say C because C is confirmed, because you see the angle C is same as angle D. It's included angle, right? Angle C and angle D. Or if I'm going to call it as X degrees here, whatever. So C and D coincide. Then AC is single stroke. AC of the first triangle is equal to DG of the second triangle. AC is opposite to vertex T. I'll call it as Y degrees. And AC is equal to DG. DG is opposite to vertex O. So this will be my Y degree. So I have O here. Yes. So T is O. See, T. T corresponds to O. So whatever is left over is A. That has to correspond to your G. Okay. So here you need to remember that I have not given you the three sides. I've given you two sides and the included angle of one triangle. That's enough. That's enough to establish congruency. If two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle, the two triangles are congruent by SAS criterion, and other things will fall in place. So obviously the other angles, if this is Z degrees, this will be Z degrees. The third side AT here will be equal to OG, that is the other third side. So these things will anyway fall in place. This is about SAS criterion. Two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. The two triangles are congruent by SAS criterion. Okay, next criterion is the ASA, or the angle side angle criterion. Here two triangles have two angles. Yes, that is two angles are given to you. Yeah. So you have two triangles. Two angles of one triangle are equal to the two angles of the other triangle. And the third angle is not given, but the included side is given. Yes, the side common to both the angles, that's given. Yes, in this case, if we put single strokes, CAT and DOG. So here, of course, it's two angles are given, so it's easy for me to write the symbolic correspondence. Angle D goes with angle A, and if you see T, so here, if I'm going to, okay, I've written dog first, I'll write cat later. So here DOG, so D corresponds to A, and OG, that is the next one is O, right? So we're done with D. O is double stroke angle, so corresponds to T, and the G corresponds to, of course, C, the leftover vertex. So here again, it's given clearly, right? AT is equal to DO. Yes, it's the included side. So the side between this is X degrees, this will also be X degrees. And if this is Y degrees, this will also be Y. Yes, the side common to angle X and Y in the first triangle will be the same as the side common to X and Y in the second triangle. Yes, AT is the included side for angles X and Y degrees, and DO is the included side for angles X and Y degrees in the second triangle. And that's why it's a case of ASA. Two angles are equal and the included side, the in-between side are given. And that's what it is about ASA out here. Yes. Now there's another variant of this, or a version of this. So this is also known as AAS. Why? Now this is because of the angle sum property. Okay. To just give you an example, now suppose I have, let's say, cat, and I'll give you another triangle, let's say hen. For some reason, I'll just say that angle C is equal to angle H, and angle T is equal to angle E. Now, by ASA, I mean, I'm to give you CT. I should be, if I'm going to talk about ASA, CT should be equal to HE, but that's not the case here. I'll say, now what's opposite to vertex C? Let's say this side AT, and here C corresponds to H, angle H, right? I'll say this side is same as En. Yeah. I'm telling that angle C is equal to angle H. Look at the strokes. And angle T is equal to angle E. And AT is equal to En. So here two angles are given, of course, and the included side is not given. If included side should be CT in the first triangle should be equal to HN of the second triangle. That's not the case here. So it's not ASA. There's two angles and the other side. So AT, if you look at this triangle, AT is equal to En. And AT is not the included side. It's opposite to vertex C. Vertex C coincides with vertex H, and the opposite side in the second triangle and the corresponding side would be En. Yeah, AT is equal to En. So sides, the corresponding sides are equal, and it's not the included side, and that's why it's a case of AAS. Suppose if this is x degrees, this also would be x degrees. Then if t is y degrees, n would also be y degrees, not n. Here E which should be equal to y degrees. This is y degrees. I'll just change it here. Okay. So if this is y degrees, this also will be y degrees. This is x, isn't it? Okay. If this is z degrees, and this would be z degrees automatically, because x and y are given. X and y, suppose x is, let's say, 40 degrees, y is 60 degrees, then z will be 80 because of angle sum property, 60, 40, 80. The same goes here. So if two angles are given, the third angle has to be the same, isn't it? And now AT, now if you see, AT is the included side for z degrees and y degrees of the first triangle, these two I'm talking about. And likewise, En becomes the included side. That's because we found out z. Now, if you're directly going to use it without going to account for z or speak about z degrees, because initially only x and y were given, it would be a case of AAS. Yeah. So if the side given is not an included side, then you have to go with AAS. The corresponding sides are equal. Otherwise, it will be ASA. So AAS is just a variant of ASA. The next important thing, which is also very important, keeping trigonometry and other higher concepts in mind, is your RHS criterion. Right angle and the other side. Right angle side. So R stands for right angle, and it's explicitly only for right angle triangles here. So you cannot use this criterion for any other triangle. It has to be a right angle triangle, and you know right angle triangles, they follow the Pythagorean theorem. The longest side in your right angle is your hypotenuse, which is the side which is opposite to 90 degrees. If I'm going to mark them as CAT and DOG, obviously in the first triangle, CT is your hypotenuse and DO is the hypotenuse in the second triangle. All right. So the longest side, because the longest side obviously in a right angle triangle is your longest angle is 90 degrees, largest angle is 90 degrees. The angle opposite to your 90 degrees has to be the longest side, which is the hypotenuse. The other two sides are called as the legs. The non-hypotenuse side becomes the legs. Legs are CA and AT. In the first triangle, it's here, CA and AT. In the second triangle, the legs are DG and GO. So what does this RHS criterion say with respect to congruency? If in two right angle triangles, so we have specifying two right angle triangles, if the hypotenuse and one side of one right angle triangle are equal to the hypotenuse and the other side of the other right angle triangle, yes, the two triangles are congruent by RHS criterion. Yes, so this is it. You need to be given the hypotenuse. Hypotenuse should be given for a right angle triangle, and the other side has to be given. Then we can say that the two right angle triangles are congruent. Yes. So the other things we can check that CA will be equal to DO, CA. Now, because of CPCT, now once you establish congruency, once the two triangles are congruent, other things follow, right? Like you know, if you're going to establish a symbolic correspondence, triangle cat is going to correspond with what? Now, C is angle A, of course, is 90 degrees. Angle G will be 90 degrees. It will be the center. Now, single stroke is opposite to vertex C. Single stroke in the second triangle is opposite to vertex. It is opposite to vertex O. So C corresponds with your O, and this should be D. And this speaks a lot, as I said. The symbolic correspondence speaks a lot. So obviously, by CPCT, the corresponding parts of congruent triangles, we can say that CA will be equal to OG, isn't it? The third side, yeah? The other side will also be equal. And other angles. So you look at the symbolic correspondence. C coincides with O, isn't it? Angle C will be equal to angle O, and angle T corresponds to vertex D, will be equal to angle D. And see, these are the things. Again, the same things, angle sum property will be satisfied, and also the Pythagorean theorem will be satisfied. You need to know one thing, that when we can also get the third side using the Pythagorean theorem. Yeah, for the first triangle, it is CA the whole square. Side CA square plus AT square will be CT square, which is my hypotenuse. This is like my leg 1. CA is leg 1. AT is leg 2. Square leg 1, square leg 2. The same thing goes for the second triangle. DG square plus GO square will be giving me DO square. So this is it. And of course, you can use your Pythagorean triplets. They are in plenty. The most commonly ones that we always speak about are the 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41, 11, 60, 61, 12, 35, 37, 16, 63, and 65, 20, 21, and 29. So there are many like this. These are the triplets, okay? So lastly, before we wind up, what is congruency and similarity? Again, congruency is used to, congruent means we're going to describe shapes or triangles or quadrilaterals where exactly they have the same shape and the same size. That's a buzzword in congruency. Yeah, here we were specifically talking about triangles. Similarity is when you describe shapes where the size is the same, but the shape and the shape is the same shape, but size can vary. The size can be different. Yes. So this is all about congruency. I hope the session has been helpful to you.